Well, hello. We're going to do a review for the last quiz. It's going to be a double quiz because it's both a quiz on Laplace transforms and convolutions, as well as on solving general second-order equations, and I'll explain how it works. So here's my first example. Let's do this one. Y double prime minus 6y prime plus 8y equals f of t. And so y0 is 1 and y prime 0 is 2, the initial conditions. So what I'm going to ask you is to do a couple of things. And the first thing I'm going to ask is solve in terms of a convolution integral. And when you see when we solve it, you'll see what I mean with that. I'll point it out again. The second thing I want you to do is then use what you find here. So let me write it that. Use your solution. I'll spell it out a little bit that you get used a little bit. Solution of 1 to find there's a solution in case f of t is 2e to the t. And then thirdly, solve the same equation using this f with the bandits of chapter 5. So this is how this quiz will be. So and I'll explain each time what I mean with each of them. I'll come back to it when we solve in there. So let's start with the first one. It's clear there we have to use Laplace transform. So this is from chapter 8. Perhaps I should also say this is using the techniques of chapter 8. So what does that mean? That means that in this thing, what we're going to do is apply the Laplace transform. Okay, and we standard thing is to say the Laplace transform of little f is capital F and of little y is capital Y, and then so if we apply this, we get L double y minus 6 times L y plus 8 Laplace y equals Laplace of little f, which is capital F. Okay, and then we have the formulas for the Laplace. So I'm not going to repeat them here. You can look them up in the book or in the lecture video. So this is s squared y minus. So in general, we get here. So we get one term here and we get another term here. And in here we put in the initial condition at 0, and here the derivative of the at y prime 0. So here's y0, that's y prime 0. So in this case, this would be 1 and 2. Okay, so let me get rid of all these things now and write down what the actual numbers are. So as I said, this is 1, so we get just minus s, and this is minus 2. Minus 6 times, and then we get sy minus 1, the y0, plus 8 capital Y, and that is capital F. Okay, then we have the terms with a y in. We have an s squared minus 6s and a plus 8. That's of course the characteristic equation, but we know that now. And what else is left? We have a minus s, a minus 2, and a minus plus 6. Okay, so if that is f, so if I bring this to the other side, I get y. Let's not divide yet. Let's take our time to do the division here. So we get capital F, and that is this is plus 4, so we get plus s minus 4. Okay. Let's see. Also a little bit that I'm not going too much astray. Okay. Okay. So far so good. So what do we do next? Well, we now solve for y. That we definitely do, but we don't put this on common denominator. We treat these two things differently. This is the expression in S, and this is the capital F that we don't know. And so for the first one, I'm going to write this as a product, really, of F and the reciprocal of that polynomial, and then here this I really write as a fraction. Because why do I do this? Well, there are two different things I'm going to do. On this one, what's the next step I need to do? I need to take, I take the Laplace transform, but I have to go back, so I'm going to take the inverse Laplace transform, so this is going to give me little y. So what is this going to be? Well, this is a product of two Laplaces. Well, we don't know yet what is the Laplace of, but that's something we're going to calculate. And we know that if you have the product of two Laplace, that is the Laplace of the convolution. Okay, so here we will get a convolution. What is this? Well, we know how to calculate the inverse Laplace of this guy, and also of this guy, but the same technique, that is partial fractions. So we're going to have to find the partial fraction for this as well as for that. Now, locally it's the same denominator, so let's start with that, right? So the denominator, of course, is easily factored in s minus 2 times s minus 4, okay? So we know that this fraction here, so let's write down our partial fractions. We know that this one will be 8s minus 2 plus bs minus 4, or in the other order, doesn't matter here. And but using Heaviside, we can easily calculate this a and b. We know that this, what we do is s minus 4 over s minus 4, sorry, yes, I didn't notice this. Right. I did this on purpose. And I forgot that I did this on purpose. So if you didn't notice this, you keep going, right? But of course, now once you write it here, you realize, oh wait, there's something going on here. S minus 4, S minus 2, the S minus 4 cancel, so I get only 1 over S minus 2 left. So that can happen, of course, right? So in this particular case means this term is not there, it's just this one, okay? Okay, so so this one, so we know that this one actually is 1 over s minus 2, simply because we can factor away the s minus 4. Now, that doesn't still make it completely trivial, because we still have to do this guy. And so what is we also have to write this one, s minus 2 times s minus 4, again in the same fashion, and this time it doesn't cancel because there's nothing to cancel on top. Okay, so let's calculate it. So here we now use Heaviside, so we didn't use it there, right? And so we take this fraction, let me copy it again, s minus 2, s minus 4, and we plug in. We want to calculate a first, so we plug in 2 and sketch out 2, because otherwise that would give me 0, right? And so I get 1 over 2 minus 4, negative 2. Okay, so a is negative 2, and what is b? Well, let me just, it's so little, so not much to copy, so let me do it. So now I do plug in 4, of course I have to cancel this one, and I get 1 over 2. Okay, so I get minus 1 over 2 s minus 2 plus 1 over 2 s minus 4. Okay. All right. So let's now let's work it out. Let me copy it. Otherwise so y is equal to capital F times let's put out a half here. Here, and I'm going to write it in this order, that the minus sign is inside. Okay, so this is this one, right? Plus, and then this one we said this cancels to 1 over s minus 2. Now, we know what these things are, because all these have power 1, so it corresponds to a variable, this is a variable in the denominator power 1, so it will correspond to 1 lower, so a constant. And the same for here. What is this minus 2? That's are the shifts that come from the exponentials, okay? So we know that the antiderivative of this thing is going to be, sorry, I mean to say, the inverse Laplace of this, no, sorry, I should perhaps do it here. What is the inverse Laplace of this then? Let's write it up here, because we, the inverse Laplace of this one is a half. I'm writing it in this order, but I'm writing this one over here, right, for the moment, so that just that you see the calculation. This means a shift by 4, right? This is a, right? Remember, the shift is s minus a 4t minus a 2t. Now, how does this factor in this? So here now I'm going to take the inverse Laplace. So this, of course, becomes little y again. Now, a product becomes a convolution. And we have to take the inverse Laplace of capital F, which was just little f, that's how capital F was defined. And then we do the convolution with a half e for t minus e to t. That is the one I had here. Okay? Plus, I now do the inverse Laplace of that one, which is e to t. And that's it. Okay. So what is this the answer? Well, let's see. The answer says solve in terms of a convolution integral. This is a convolution product, but a convolution integral, what is the next step you have to do is just write down what this convolution is. So that is a little bit of copying things correctly. Remember, these are functions of t, but we put z in the first one, and we put t minus z in the second one. What do we do with the second one? In this one, do you also replace c? No, this is not an integral. This is just on its own. There's no integral here. Okay, so this is the answer to the first question. So that is what I meant with saying, let me read it again, in terms of a convolution integral. So I want you to do all this work to get to this stage. There's still some calculations to be done, right? Exactly. Okay. Now, what is the second question asking? It says that, okay, now that you have done this, do this now for this particular function. So meaning what? Well, in this integral, replace f, so f of t is now, what was it? 2 times e3t, 2e3t. Okay? All right. So we plug in this one in there. So what do we get? So let's look at the integral. So the involution integral. I'm not copying this part because this one is always the same, right? So let's do this one is from 0 to t. E3z, and this is, here you have to be extremely careful because there are t's and z's and they have to be the right ones, otherwise it comes out differently. So this is a function, but it says here you have to plug in z. This function, we have everything already as it's supposed to be. There's a half that I can factor out for simplicity here, and then I have a e 4t minus 4z, I like to write it this way, minus e, there's a 2, right? 2t minus 2z. And in fact, let's also split these two exponentials as products, right? They're really products. So, and why do I do that? Because I want to separate the t's, which have nothing to do with the integral, and therefore can come out the integration, with the z's, which are I forgot that. So, but now I know for sure that z is the one that I'm indicating with. So I'm going to do this as well here. I'm going to cheat a little bit. So this would be e to the minus 4z now, and e to the minus 2z. Okay, e to the minus 4z, e to the minus 2t. Okay, so now this is the integral that we have to calculate, and it's not a hard integral. I'm saying, in general, if these f's are a bit weirder functions, then this becomes a very difficult integral. But I chose functions where it is possible to do. Okay, so let's see what it is then. So get a half from 0 to t. What do we do? Well, expand. So let's see. We have 2 powers of z here. So if I add them up, I get e to the minus z. And then I have this e to the 4t. Now, that I can take out, e to the 4t. Okay? And that's the only thing left, dz. Now, I'm going to split the integral. So I should have said that. Perhaps I'm going to make it into two integrals, right? So I'm going to put here a second integral sign, and let me not write it, but I'm going to write it now. So minus a half, and let's see, what is the e to t? That can come out because t it's not the integral. And then from 0 to t, and what do I have then? E3z times e minus 2. I wrote t, and it should be z. I think it was a z, and it might be a very bad z. Okay, so E3z times E minus 2z, that is actually EZ. dz. Oh, okay. Sure, okay. We're still working on the integral. So, now everything is actually just, let's see here. And the deriving, this is e to the minus z over minus 1. And we have to evaluate between 0 and t, minus a half e to the 2t. And we get e to the z, which the derivative is just e to the z, right, between 0 and t. Now, again, be very careful when you plug in this t and 0. Now, and only plug in the right spots. This is the part, we can only replace z's by t's. Don't go start putting everywhere else these t's or the zeros. That's even where you can make more mistakes. So let's do this for the first one. We have half e for t. That's a constant so far. Now we plug in t, that is minus e to the minus t, right? The minus sign brought it up. Minus, so plus, plug in 0, that's 1. So, okay, I'm plugging 0 here, that is 1, right? And I have a 1 over minus 1, but since I have to subtract, I get a plus. So this is the result of plugging in t 0. What do we get here? And very careful here with the negative signs as well, right? et minus e to the 0 minus 1. Okay, so let's see what do we get here, right? I'm going to expand again. I get a half e 4t minus a half then, e to the 3t, okay? The second term is a half e to the 4t. The next term is minus a half e to the 3t, e to the 3t, and the next one is e a half e to the 2t. Okay. Okay, so what we have, do something, no, nothing cancels, we have, ft is e3t, and it was 2 times e3t. I knew that there was no, that fraction should have gone, so I forgot to plug in the 2 here. So there was a 2 here, which therefore makes these fractions go. I'm sorry, I put in the wrong t here, so there were no fractions. These halves are all gone. I wanted to keep it simple, and now I kind of screwed that up a little bit, didn't I? So this is a minus sign here, be careful. Minus sign. So we get minus, we get minus 2 times e3t plus e to the 4t plus e to the 2t. That's the solution for this particular forcing function. Now, what is the third question asked? The third question asks now, okay, yeah, if this is the forcing function, and this is constant coefficients, you know how to do this in chapter 5. You use the methods of chapter 5. So you start from scratch, although a lot of work has already been done, and do this with the methods of chapter 5. Meaning to say, so be clear, this is, I'm trying to explain, this is how the question will be, okay? So understand the phrasing of the question and the three different things that you have to do. So now we have to do y double prime minus 6y prime plus 8y equals 2e3t using the methods of chapter 5. So step 1 was the complementary homogeneous. Complementary homogeneous. So we get y double prime minus 6y prime plus 8y is 0. This leads to the characteristic equation because it's constant coefficients. An equation that we have already encountered. In a different form, but let's use a variable here, I don't know. Let's use z, I guess. I don't want to use t because t is the variable of integration, the variable of the function. So z squared minus 6z plus 8 equals 0. We know that we have to factor this as 6 minus 2 times 6 minus 4. So we get 2 roots, z is 2 and z is 4. Perfect. Okay, so these are the 2 roots. So once we have these roots, we can write down the general homogeneous equation. These are the 2 coefficients in front of t inside in front of the exponent here, right, for t. And so a and b are still to be determined. Okay. So what is then step 2? Then step 2. What does this step 2 do? Okay. So analyze this. This is of the form an exponential function times a polynomial. Here it's a constant, 2. Okay, but in general this could be a polynomial. And don't count it out that I do that, okay? So what you have to do then is, you say, we have to first get rid of this exponential. Let's do that first. How do you do that? By the variation of parameters, you just replace, you multiply e3t with u that you then can calculate. So let me box this because we're going to go back here to find our y. Okay, so what is y prime? That is u prime e3t plus 3u u e3t, sorry, yeah. Y double prime is u u double prime e3t plus 3u prime e3t plus, now do the same for the second term, 3u prime e3t plus 9u e3t, okay? And then we plug that into our differential equation here, the original one. We know that by virtue of this substitution, this exponential has to be factored out. So what do we have left? So y prime, we have a u double prime here, we have a 3u prime and 3u prime, that's add up to 6u prime, and then we have a 9u. Okay, this is y double prime. So now minus 6 times, don't forget the coefficients, right? Minus 6 times y prime, and y prime is u prime plus 3u, and then plus 8 times y, which is just a u. Okay, so this is what we get, and this should be equal to, 2 times e3t. Okay, good. We know what has to happen is that these guys go. Okay, so what do we have left with? Let's write it out. We have a u double prime plus 6u prime plus 9u minus 6u prime minus 18u plus 8u equals 2. Before we go on, do you think the u's are going to cancel? When does the u cancel? It's good to know this. It's important to know this. Namely, there will be this alpha here. This is, we call the alpha in our calculations, right? This is not a root. And that's the more general situation, that it is not a root, because, I mean, it has to be kind of bad luck or good luck, depending on how you see these things, for that to be exactly one of the two roots, right? So it's not a root. That means there will be no cancellation of u. It's when this is a root, then there will be cancellation of u. And even if this would be the only root, because it can be that this equation has only one root, if the discriminant is 0, then it's even u and u prime will cancel. So it's good to know in advance whether this thing will happen or not. So it should not happen here, and it's not. What we have is, let's see. Oh, the u primes do cancel. Now, that is something that we cannot predict, that can or cannot happen. That cannot make any conclusion of that. But what we see is we have a 17u minus 18u to get minus u, and that is equal to 2. 17, yes, okay. So what do we do next? Well, now we have reduced it that the right-hand side is a polynomial. So we're going to do undetermined coefficients. And what we have to plug here is a polynomial of the same degree as the one that we have on the right-hand side. This is degree 0, so in other words, just a constant here. Okay? And what about any t or something like that? No. Since this is not a root, we don't have to multiply with t. If this were a root, we would have to multiply with t. So keep that also in mind. So here we don't need to multiply with t, so we are happy with this. And so what we now have to find is what is a? Well, u prime is then 0 and u double prime is 0. Seems like kind of weird, right? But okay. So what do I get if I plug in? So 0 minus a is 2. Oh, okay, so a is negative 2. So we see that the solution here is negative 2. For u. So u is negative 2 is the solution. Right? Here, this is u. So what is y then? Well, remember, we get y here, right? So y is minus 2 e to the 3t. And now we put everything together. Step 3. So the general solution, this is a particular solution, let me write the p here, is this particular solution, 2e3t, plus the general homogeneous solution, which was this one, right? I don't know, yeah, I didn't switch it out. So A and B are now still to be determined, new A and B's, right? And they are determined from the initial conditions that if t is 0, then y was 1 and y prime, I guess, was 2, right? Yeah. Okay, so if I plug in 0 in here, then I get 1. And here I get, but be careful, there's something here. There's a minus 2 there, plus a plus b, because the exponentials are both e to the 0 or 1. And if I plug, now, okay, I need the derivative. So let's calculate the derivative. That is y prime is minus 6e3t plus 2a2t plus 4b e to the 4t. and if I plug in, then it's 2 equals minus 6 plus 2a plus 4b. Okay, let's put everything on the side. 3 is equal to a plus b, and the other equation says 8 is equal to 2a plus 4b. So let's multiply this with negative 2 and add up to there. So negative 2 times 3, that's negative 6, and adding that to 8, I get 2. And then negative 2 times plus 2a, that cancels out, so I get negative 2 times b plus 4, but that's 2b, so I see that b is 1. Okay, and so once I have 1, I can plug this in here. So 3 is equal to a plus 1. So I see that a is equal to 2. So, conclusion, my solution is y is minus 2e3t plus 2 times e2t plus e4t. And now comes the big moment of truth. Is this the same thing that I found here? And it isn't. Everything is except for this 2 here. That's why I got a little bit suspicious that my a was 2 there. Okay, yeah, no, that's correct. So, wait, let me see here. I must have done something silly somewhere at some point. So I don't know in which one I made a mistake. That's the problem. So, okay, so they should be the same. Why? Because they're two different methods, but they should give the same answer. Now, one is wrong and one is correct. How do we know which one is wrong and one is correct? Of course, you can plug in and try to figure out. But let's think about it. Perhaps we can tell already from the initial conditions whether which one is right or not. Let's verify the initial conditions. So if I put in t equals 0, my y should be 1, right? But that's not the case. If I plug in, I get minus 2 plus 1 plus 1. So there is something wrong here. This one is wrong. So you see, sometimes just plugging in the initial condition and even only one of them can you already tell you that, oh, you made somewhere probably a minus error that I made. So let's try to trace it back here. So the place where I would expect it to be is here when we integrate. That's it is the problem. It comes with the e2t, right? So it's this integration that we somehow messed up. There was a minus sign here. Okay, e2, ez, we plug in t and 0, that is et minus 1. So, well, what is this half here? Okay, at some point I was this half that there was not there anymore. Right, this 2. I said all these halves are gone, right? But perhaps I don't know, this is... Well, this is weird. Where did I go off the rails here? Oh, here! And this is why you... it's harder on the screen because I have to keep scrolling up and down, so I kind of lose track of things. This guy, I forgot to add this guy, right? I was always doing this integral, and that was the integral, but there was also, so what I forgot to add here is the plus t, 2t. So again, the way to check this is by looking at, so I'm going to play, this e2t comes from the fact that I had it here. That was the tail that I said I'm going to do this integral here, right? All this was the integral. All the way up to here, this was the integral. So if you want, this was a side calculation. Right? This is all on the side. And now I'll put everything together. The integral plus whatever it was. And so this will actually then give me minus 2e3t plus 4, so e to the 4t plus 2e to the e2t. And that's exactly what I found here too. So now it matches. So that's the advantage of this question, is that you can check your answer. At least you know the answer should be the same. Let me do some more question, perhaps, just to get used to what I mean here. So I'm not going to spell it out anymore, but it's the same question here, a type of question. So like y double prime plus 6y prime plus 13y is f of t, and the initial conditions are y0 is 1 and y prime 0 is negative 2. Okay, and so that is A1, solve this. 2 is now do this for ft equal to 4t e to the minus 3t, and then 3 is again, so it's the same questions. I'm not copying them anymore, but with a different forcing function. Okay, so now my forcing function is this one. Okay, but I first have to do it with the general forcing function. So in the for one, I have a capital F here. I'm not working with this. I cannot do the particular one yet. So don't do that yet. Okay, you have to first do it with general little f. Okay, and then so little y corresponds to capital Y. So we take the Laplace of this guy, right? So this would be, I'm going to write it down already, s squared y minus the y0 s minus minus plus 2 plus 6 times s y minus 1 plus 13y. Okay, and that is equal to capital F. Sorry, let me move these guys on the side a little bit. So this is equal to capital F. Okay, so we get s squared plus 6. Oh, there's an s missing here. The s, I wrote the s on top of the y, or the y on top of the s. 6s plus 13. I know that this has to be the characteristic equation. Okay, y, and then I have a minus s plus 2 plus 1 plus minus 6, and that is equal to capital F. Oh no, yeah, right. Let me not do the fast here. S squared y 6sy 13y. Okay, minus s plus 2 minus 6. Okay, so this would be minus s minus 4 therefore, and so we get s squared plus 6s plus 13. Y equals f plus s plus 4, and now we do the dividing, but again thinking of these as two different things that I have to do here. The first one will be again giving this convolution integral, the second one will just be inverse Laplace. So what is the next one? Well, now comes the partial fraction again. So you see in this type of question there's always two partial fractions you have to calculate with the same denominator locally. So what is the denominator here? So let's factor this, right? And of course you try and it doesn't work. Why? Because it's a quadratic irreducible. And you can use the quadratic formula, but this doesn't help us here. We don't need the roots. So here the quadratic formula is not helpful. I hope you understand that, although, okay, it will give you the root, but what are you going to do with that? Right? This is not the form that we're going to use. What we need to do is we need to complete the square. This is not a step you can skip. It's not in previous cases we sometimes completed the square to find the solution. That was just a way of solving an equation. But now we have to complete the square. So the technique is always the same. You split off the s's, and then you divide this number by 2. So divide by 2. That gives me 3. And then you square it and add it up. So there's this plus 9. But of course, if you add 9, you should subtract 9. So minus 9. So what you get is s plus 3 square plus 4. That is what this guy is. Okay. So what does this now mean? Well, let's discuss this one first. This means our partial fraction has to be for s plus 4 over s squared plus 6s plus 13 is going to be of the form, let's think about it, a s plus 3 plus b over s plus 3 squared plus 4. Remember, this is the completing the square tells us we think of it as a polynomial in s plus 3, or perhaps a bit more fancy, centered at negative 3. But then the top also should be written as a polynomial of that type. Okay, so that is what we need to write here. Okay, so we have to write the top in this way. Now you might even actually see it here, what the A and B are, but let's just do the calculation. Okay, let's just go through the calculation. How do you do this? Well, clear the denominators. So we clear the denominators. So that will give me s plus 4 is equal to as plus 3 plus b. Okay, so okay, that's the equation, right? This is simple because it is already an s squared plus 3. Well, okay, perhaps I'm making it, perhaps I should not say it this way. Let me make it, give you the simpler solution, right? Because I said you can see it probably, and yes, you can see it because I said what we need to do. So let's do that. I said we have to write the top, because there is nothing else here. If there would be more factors here, yes, then I have to do other things. But there is nothing else here. So this I have to write as a polynomial in s plus 3. Okay? And this is not hard to do that. So I can write that here. Let's do it right away. In fact, it is s plus 3 plus 1, right? And if you don't see this, well, remember what you do is you write s as s plus 3 minus 3, and you plug that in. If I plug that in s plus 4, I get s plus 3 minus 3 plus 4. That's exactly what I got there. Okay? So we have our partial fraction. We know what it is. Okay. Yep. Good. What about this one? Well, yeah, here it is. You get it. Well, okay, fine. Yeah, I mean, this 4, right? It's the one on top, so we are done. Now, we know what these things are. Let's think about what do they mean here. And okay. So we know what do we have to do then? Once we have written it in this partial fraction, we have to split it, right? In two fractions here, because we're gonna use the plus 4, and here is an s plus 3 squared plus 4. And we're gonna, if we do the inverse Laplace, so let's do this here, calculation on the side. What is the inverse Laplace? Well, we know that when, let's analyze this. There are two things here. There's a shift, so a is negative 3 here, and there is an omega, which is 4? No, 2, right? Okay. So this, we know with the variable on top is the cosine. So this will be cosine 2t, omega, and e minus 3t. That's the shift is minus 3. And here, the same thing. The shift is going to be e minus 3t. It's plus, right? It's just adding. But be careful here. There should be a 2 on top, which we don't. So we have to take a half sine 2t. So I remind you, the Laplace of sine omega t is omega over s squared plus omega squared. Okay? So this means that 1 over omega, the Laplace sine omega t, is equal to 1 over s squared plus omega squared. This is what we're using. So we have this 1 over omega here. That's the 1 over 2 here. Okay, that's that. And what we get here, we also need the Laplace, the inverse Laplace of, sorry, I got a little bit, yeah, of this guy, right? What is the inverse Laplace there? So sorry, I'm going to write it here. Well, it's the same thing. It's the sign, right? Because again, remember, okay, I shouldn't have written in this form. This is, okay, let me, remember we have now factored this thing, so let me write these factorizations here that we actually have, then it's clear what I'm doing, right? So this is s plus 3 squared plus 4, s plus 3 squared plus 4, and then this we wrote it s plus 3 plus 1. Now this is, again, the sign, but for the same reason we get 1 over 2 sine, sorry, there's an e there for twisting. Don't forget the twist always, e minus 3t sine 2t. Good. So now we have all the components. Let's put it all together. So this one we're going to do the inverse Laplace. Sorry, got a little bit. We did all the calculations separately, but let's now put it all together. Why? Of course, the inverse Laplace of capital F is little f. The inverse Laplace of this guy we just did is this guy here. So it's a half e to the minus 3t sine 2t. Plus, and then we have these guys here, which in the end we shouldn't forget, which I did last time, so hopefully I won't do it in this question. but if I do, please yell, and I hopefully hear you. Sine 2t, okay? So now we have to write this integral from 0 to t, f z a half, let's bring that half out, and then here, well, there's only one term, so no need for this, e to the minus 3 t minus z sine 2 t minus z, so 2z, let me already, in fact, well, let me not write that, let's do this in this next step, otherwise you say, why do you do this? dz, okay, and then plus these two that I'm not going to copy anymore. So that is our solution, okay? In the general situation for general f. So now the second part of the question is, now, and only now, you can say that f of t is equal to, what was it, 2t, oh, where I wrote this question. Here. 4t e to the minus 3t. 4t e to the minus 3t. So what we need to calculate is now this integral here. So let's write down this integral. So again, the involution integral, that's not the whole thing, okay? I'm talking to myself now, because otherwise I'm going to forget it. So a half, 0t, we plug this guy in, but we replace t by z, so 4z e to the minus 3z. Then we have an e minus 3t e to the minus plus 3z. I'm already splitting this e in this way. And then I have a sine 2t minus z. And for reasons that we'll see later, I'm not even bothering splitting this. Plus, no plus. I'm just working on the integral itself. So first of all, the 4 comes out. Okay, and the e minus 3t comes out. Because that's what it is, right? They are constants. So what we are left with is a 2 e to the minus 3t from 0 to t. I wrote 4 here, I don't know why. T. And then we have a z. The e's actually cancel out. So we have a z sine 2t minus z dz. That's an integral. I don't know, perhaps, okay. I think I know what to do. Because it's what is this? What type of integral is this? Well, perhaps the best thing here to do is a little substitution to make it. So let's look at the integral itself. So again, on the side. So on the side, I'm going to just calculate the indefinite integral. And then later we deal with the zeros and t's. So let me write the integral again. Sine 2t minus z dz. Now this 2t minus z bothers me. That is a very complicated thing where t is a constant, but z is not. So I'm going to take the substitution, u is 2 minus z. So this is just from Calc 2, right? This is not parameters or anything. That is just u. If that is u, so that would be 2t minus 2z, right? What is du then? Well, u is a minus 2 dz. Okay, so if you want dz is equal to minus a half du. Okay, so that's that. And so what is z then? So okay, now you say, okay, professor, but how are you gonna? That's not what you do with substitution. The derivative of u is not there. Well, the derivative of u is just 1, so it's kind of there. But what are you going to do with the z? Don't forget there's a z here. Well, yes, so we have to solve for z here. Now, there's a 2 here. There's a reason I put a 2 here. So let's keep the 2 also in here. Just so that we don't have to deal with fractions. So I'm going to put this in a 2 here too. Because now, see, it's much easier to solve for 2z, right? So solve here for 2z in this equation. So that means that 2z is 2t minus u, right? Okay, so we can plug that in. So we get 2t minus u sine t, and dz was minus a half du. Okay. So, what did I say? 2t minus z, that is u, not t. What am I doing here? This is u, right? So, okay. So now, what are we going to do with this one? Well, we have a sign, and the 2t is a constant, and u is not. So perhaps we should split this. Okay, let's split this. So the first part would be, so I'm going to split this one here. So there's a 2t and minus a half. So these cancel against minus t sine u du, right? The other one is minus minus plus a half u sine u du. Yes? Okay, good. What is this, the first one? That's very simple, because that is just, the t is a constant. So this is minus t cosine u, derivative of cosine is minus sine, so actually is a plus here. Okay, so that's the answer of that. What do we do here? Oh, okay, that seems to be integration by parts. So I'm going to do this again on the side. So on the side, I'm doing another side. So side calculation again. So I have to calculate this integral, but I'm going to, for now, call it x's. I have to remember that eventually it's back u's, because integration by parts uses u and v, and I don't want to get confused here. So what do we do then with complication? Isolate, right? So remember isolate. And so what we have as a trig and an algebraic. So the algebraic becomes u, and the trig dv is sine x dx. Okay, so du is dx, and then v is the antiderivative of sine, that is minus cosine x. Okay, so this is equal to uv minus integral v du. So that is minus x cosine x minus cosine x dx. And the antiderivative of cosine is just sine. So it's minus x cosine x, minus minus is a plus sine x. The derivative of cosine is sine. Okay, so this integral is a half, and instead of x's I should write u's now. Minus u cosine u plus sine u. All right, that's what we have. Now we can combine this, these two here, cosine u's. This is t minus a half cosine u plus a half sine u. Now where does the u come from? Now that u was in, so we should mark every time we doing these substitutions, right? U was a substitution here. So this was this substitution. I'll do it in a different color here. This was a substitution. So we should plug back in what u is. U is 2 times t minus z. So we get t minus a half cosine wait. I forgot my u here. Here. There's a u here, sorry. T minus u over 2. I knew there was somewhere a u, so hela. Okay, t minus u over 2, okay. And u was 2 times tz, sorry. So this is what I have, this is where I was almost wrong. So let me do this over again, okay. So this is t minus, u was 2 times t minus z, and I have to divide it by 2, right? And then cosine 2 times t minus z plus a half sine 2 times t minus z. Okay, these two cancels, and then I get t minus t plus z. So I get actually z cosine 2t minus z plus a half sine 2t minus z. Now, what was this? This was a side calculation here on the side, where I was calculating this guy here, okay? So let me now, actually, I'm going to erase some stuff here, okay? Continue with plugging this in, this integral, right? We're still doing this integral only. That was, again, the side. On the side, we were doing integral. So this was, well, with 2. Oh, no, the 2 we took inside. So we have to be careful. We calculated this one. So we have an e minus 3t. And then we have what we just calculated. This whole thing was equal to z cosine 2t minus z plus a half sine 2t minus z. Right, and that's between 0 and t. So now we're going to have to plug in 0 and t still. Okay, e minus 3t, that is all the way out. If I plug in t, I get t. What happens if I, now remember, z is t, right? This is what you do, replace z by t. Then this becomes 0, right? So the cosine of 0 is 1, so I get t. plus, what is this one? Well, t minus t is 0, so that's 0 plus 0. That is the result of plugging in t. What's the result of plugging in z? Okay, then this is 0 because I plug in z equals 0. Now, but the sign is not. There we get a half sine, but I'm plugging in 0, so 2t. So a long calculation, we find that this is equal to t e to the minus 3t minus e to the minus 3t over 2 sine 2t. And now we put everything together because I didn't gonna make the mistake twice, right? So the solution is this, what we just calculated was our integral. That was this guy, t e to the minus 3t minus a half, let's write it out, e to the minus 3t sine 2t plus, and then we had these two tail terms that also plus e to the minus 3t. What was that? Cosine 2t plus a half, right? Was it a half? Plus a half e minus 3 times plus a half e to the minus 3t times sine 2t. Is there anything that combines? Well, even better, there's something that cancels. These two cancel. And so I get t e to the minus 3t plus e minus 3t cosine 2t. That seems to be the solution. That's using all this up to now. We were using chapter 8 material Laplace. Let's now go to chapter 5. So now we're doing 3. So we're now looking at the same differential equation. 13 equals, but now already from the bat we use the forcing function 4te minus 3t. Okay, and we have any conditions, we'll pick up with them later. So let's start here. Step 1, we need the complementary homogeneous. I'm sure by now you exasperated and said, why is this so long, Professor? This is way too long. It's a double quiz, right? It's a preparation quiz for the final. We are there almost, so yeah. There's no homeworks today, that's why there's more this kind of stuff, okay? Complementary homogeneous is, let's write it in with z's, z squared plus 6z plus 13 is 0. Now we know, now we can use the quadratic formula, but come on guys, we did it already, we know this is how it looks like. And from this it's easy to see what the roots are. 6 plus 3 squared is equal to negative 4. Take the radical of both sides, 6 plus 3 is plus or minus. The minus becomes an I, and the radical 4 is 2. Okay, remember, this is what we're using all the time. I hope this is clear, right? But we don't write radical minus 1, we write I. Okay, and so z is equal to minus 3 plus or minus 2i. Now, this is in the way that we analyze, this is what we call lambda, and this is what we call omega. And so we know that the homogeneous solution looks like, what does this do? That is the coefficient in front of t, and then this gives me the sine and the cosine. 2 omega, not 2 omega, 2t, right? Omega is 2, so omega t, so 2t plus b times cosine 2t. Okay, that we know is going to be the homogeneous solution, but now the particular solution. And that is again variation by parameters, right? Let's analyze again what we have. This time we do have we have a real polynomial and an e to the minus 3t. So alpha is negative 3. Is that the root of this polynomial? Yeah, here. No, that's not the root. These are the roots. There are no real roots. So no problem here. Alpha is negative 3. So nothing is going to cancel. It will be straightforward, which is actually, in some sense, if you've done some more exercises, you realize it's actually better that it cancels, right? Because it's easier then. But okay. So what do we need? Well, we know we're going to do this, we're boxing this here. y equals u e to the minus 3t. And so we need to calculate y prime is u prime e minus 3t minus 3 times u e minus 3t, and y double prime is equal to u double prime e minus 3t minus 3 times u prime e minus 3t minus 3 u prime e minus 3t plus 9 u e to the minus 3t. I hope everybody knows how to do this now by now. This is u. And okay, now we plug this into our equation here. So, and we know that an e minus 3t can be factored out. So for the y double prime contribution is u double prime. If we've done this so many times, we know that these two numbers are always going to be the same, minus 6u prime plus 9u. Then we have plus 6 times, right? Plus 6 times y prime. So plus 6 times u prime minus 3u plus 13 times u. And that is equal to, well, whatever the other side was 4t e to the minus 3t. 4t e to the minus 3 here. So what needs to happen happens. The exponentials are gone. And let's see what we... And u's should not cancel. Okay, let's see whether that happens. So we have a u double prime, minus 6u prime, plus 9u, plus 6u prime, minus 18u, plus 13u, minus 18 plus 13u, okay? So this is 4t, so this is u double prime, and then, oh, again the u primes cancel. Okay, that's I like that. At least makes it a little bit simpler, right? And then 9 plus 13 is 22, minus 18, so plus 4u equals 4t. Okay, so next step, what we need to do now is a new indeterminate, now this is a polynomial, so we know we have to do the indeterminate polynomial of the same degree. Do we have to multiply with t? No, because u is not cancelled. Okay, so this is how the indeterminate polynomial looks like. We need u prime, which is 4, is a, and then u double prime is 0. Okay, so we get 4 times a t plus b is equal to 4t. So 4at plus b is 4t. This tells me these two are the same. 4a is 4. And these two, well, there's nothing here, is 0. So a is 1, b is 0. That's possible. There's nobody has said that this cannot happen. So our u, in other words, u is just t. That's the solution? No. The particular solution is, remember, this boxed guy is t e minus 3t. T e minus 3t. So that's our particular solution. So the general solution is the sum of this particular solution, t e minus 3t, plus these two homogeneous ones. That was an e to the minus 3t. Sine, what was it? A times sine 2t plus b times cosine 2t. And now we need to determine a and b, so that is our y, and our initial conditions. So if t is 0, then y was 1, I think, and the derivative was 2. There's still, where are we? I should have made it a little bit, here. 1 and negative 2, okay? 1 and y prime is negative 2. Okay, so let's do these two first. 1 is equal to, what am I plugging in? T to 0. Oh, the first term is gone. The sign is also gone, so I find b e to the minus, oh, e to the 0 is also 1. Okay, so this is b. Okay, b is 1. That was quick. That was harmless. Okay. So what we need is, of course, the derivative, y prime. Now, don't forget this is a product, so there's e minus 3t minus 3 times t e to the minus 3t, the derivative of e minus 3t. Then this is a product 2 plus minus 3 e to the minus 3t a sine 2t plus b cosine 2t plus e to the minus 3t, and now I take the derivative of these guys. That's a 2 from the sine inside there. The derivative of sine is cosine. Oh, there's an a here. Cosine 2t, and the derivative of sine is negative. So negative 2b sine 2t. Yeah, for this time I wrote a sine first instead of cosine. The order, again, is not important. So let's plug in. If I plug in here, what do I get? Minus 2 is equal to, let's see, this term survives, so that it's just 1. The next one is 0. then the sign is 0 in the second line here. This will 0, but this is not. So what is the contribution here? Minus 3 times b. Minus 3 times b. And what is the contribution here? This time the sign is 0, but this is not. So this is 2a. That's 3a. Plus 2a. So b was 1. So this is minus 2 is 1 minus 3 plus 2a. That is negative 2, right? So 0 is 2a. Oh, a is 0. Okay, okay, I like that. So what is our solution? So according to this here, our solution is y is t e to the minus 3t plus e to the minus 3t. A was 0 and b was 1. So cosine 2t. And again, big moment of truth. Is this now the same? It sounds very similar, but big sigh of relief. It is the same, right? This was what I found using the Laplace, and comes down to say. You see, what is perhaps strange is that the Laplace method seems to be a bit harder, right? Because we got much more work to do. Plus, we got this term that then eventually cancelled, whereas we never had to deal with these signs, really. We knew from the start these signs were, well, here we saw that the a is 0, so there was no sign. So it's strange, right, how these two methods are kind of going by different ways. But they end up, of course, at the same destination. That is how mathematics is supposed to work. Okay, so expect something like this, okay? So there are 3 parts. In this quiz 12, there will be 3 parts. General f, and then the general f. So let me repeat it again. So one where you deal with this and don't change f. Then from what you've done here, now you can say, okay, now I'm going to replace f by that and continue. And then you start over again, this one with this f, but now using the methods of chapter 5. Okay, I've said it now many times, so I hope that this is clear, that this is what you have to do on the quiz. Don't come and yell and scream at me if you said, I didn't understand the question, what to do, I was confused. I've explained it now so many times, so I hope by now it has sunk in. All right, success.